So it's been a couple weeks since you were in this scene. I started this unit by shooting a ring off this device and talking about a complicated motion, and then discussing about how we were going to focus in on position, velocity, acceleration, and force for some simpler motions. And now you're at the eve of your first exam, and you're probably just trying to figure out what the big picture is. And I just wanted to do a quick review. For constant velocity, that's motion where there's no force acting on an object, and therefore no acceleration. Now that clearly wasn't constant velocity because it slowed down, because there was friction, which was a force. But had it been frictionless, what we would have seen was no force, and therefore no acceleration. That would mean that whatever its velocity it started with, it kept the whole time. So we had a constant velocity time graph. Now it's important to remember that velocity is how fast your position's changing. Since we had a non-zero velocity, its position was changing. And clearly its position was changing, it was moving. Since the velocity was constant, that would imply that our position time graph increased at a constant rate. So in other words, this is linear. It's important to remember that the slope of the position time graph equals velocity. So whatever this slope is, y2 minus y1 over x2 minus x1, that is how high this line is. And since this line has no slope, that implies no acceleration and no force being on it, if it had no friction. The other big motion that we studied in this first unit was constant acceleration. So that would imply a constant force. And we achieved that in this quick little demo by having the weight fall, and the force of gravity on the weight is causing the constant force on the cart. So that caused a constant acceleration. And since this is a constant acceleration, it means the velocity increased steadily. Slope of a velocity time graph is your acceleration. We had no acceleration here, so we had no slope here. Our velocity is constant. We do have acceleration here, so we have a slope, and we have a non-constant velocity. So it's important to remember that this slope is that acceleration. Now, since our velocity here is increasing, that means our position will not increase steadily like it did before. We do not have a constant slope and therefore a constant velocity graph. So that means our position graph will increase, but it will increase more and more as time passes. And that ends up being a parabola. So if you understand these relationships between these three graphs, you understand the big picture of the first unit. The rest of your studying should consist of practicing the various different types of word problems and going through how to use the different equations, which we've covered in other places and other videos.